Okay, so picture this. You're soaring through the air, thousands of feet up, going like what, hundreds of miles an hour.
Exhilarating. Yeah.
Totally. But have you ever actually stopped and thought about how pilots actually like control these massive machines? How do they make them dance through the sky?
It's all about precision up there.
Exactly. And that's what we're diving into today, the fascinating world of aircraft flight control systems. We're going way beyond just the basics lift and drag and really getting into how a pilot's input actually makes a plane move.
It's like this, see, these flight control systems, they're like the language pilots use to talk to the plane.
A whole conversation.
Yeah, a two-way conversation between what the pilot wants and, those powerful aerodynamic forces at play.
That makes sense. So to understand this language, we got to start with the basics, right? What are flight control systems in the simplest terms?
Okay, so simplest terms, they're all the parts, all the pieces that let a pilot control the direction and what we call the attitude of the aircraft.
Okay, attitude. We're not talking about a plane's mood swings, are we?
Definitely not. Attitude in aviation, it's how the plane's oriented compared to the horizon. Is it banked? Is it pitched up or down? Is it yawing left or right? That kind of thing.
Got it, got it. So it's about giving the pilot the tools to, like, maneuver through the air in 3D.
Exactly. And it's not just moving in those directions, but doing it safely, predictably, every time. And what's so cool is seeing how these systems have, evolved over time.
Yeah, from those early days of aviation, we're talking rickety biplanes held together with, like, hopes and dreams.
And now we have these absolute marvels of engineering, hydraulics, computers, even fly-by-wire technology where the pilot's commands are like electronic signals.
It's gone from smoke signals to high-speed internet, all for controlling flight. But let's not get ahead of ourselves. Before we get into all that high-tech stuff, we've got to understand the fundamentals.
We got to lay the groundwork.
And that starts with the big three of flight control: roll, pitch, and yaw.
Those are like, think of them as the primary axes of movement for any aircraft. Roll is tilting your head side to side. Pitch is like nodding yes. And yaw is shaking your head no.
Okay, I'm picturing it, trying to keep all those straight. To actually control these movements, though, you need the plane itself to have a way to do it, right? I mean, the physical parts.
Exactly. And each of those big three movements, they've got dedicated control surfaces on the aircraft to make it happen.
So let's start with ailerons. Those are the ones for rolling the aircraft, right?
You got it.
And those are on the trailing edge of the wings. I always picture them moving like a seesaw, one going up while the other goes down.
You got it. That's how they work. Pilot wants to roll right. The right aileron goes up, left one goes down, creates a difference in lift, and boom, the aircraft banks.
So far, so good. But in the research, there's something called adverse yaw, like an unexpected side effect.
It is, kind of. See, when
Yeah.
you use those ailerons to bank, you're not just changing the lift, you're changing the drag on each wing, too.
Oh.
And that can cause the nose to yaw, which is swing in the opposite direction you want to roll.
It's like the plane's trying to outsmart the pilot.
Something like that.
There's got to be a way to fix that, right?
Oh, absolutely.
Yeah.
Engineers came up with some pretty ingenious solutions, which we'll get into.
Okay, good.
But first, let's finish our big three tour. Up next, pitch. That's the up and down movement of the nose.
And that's where the elevator comes in, right?
That's the moving part on the horizontal stabilizer, back at the tail.
You got it. Pull back on the stick. The elevator goes up, increases lift at the tail, pushes the nose up, push the stick forward, opposite happens, nose goes down.
Okay, so far the names make sense, ailerons, elevators. But then it mentions this thing called a T-tail design. What's that all about?
Ah, the T-tail. It's this design choice on some aircraft where instead of having the horizontal stabilizer at the base of the vertical stabilizer,
That classic tail fin look.
right, instead of that, it's mounted at the top of the vertical stabilizer, forming a T shape.
Hence the name. Very clever. It looks sleek, but it's got its own pros and cons, like most things in engineering, right?
Got to take the good with the bad.
Exactly.
Yeah.
A T-tail might help in some flight conditions, but it can be tricky in others. We'll dig into that more later.
All right, color me intrigued. But for now, back to our big three. We've got roll with the ailerons, pitch with the elevator. That leaves yaw, the side to side.
And for yaw, we have the rudder.
Mm-hmm.
It's usually on that big vertical stabilizer, the fin at the tail.
So this one's pretty straightforward, right? It works just like a rudder on a boat.
You got it. Left pedal, rudder goes left, aircraft yaws, swings its nose to the left, and vice versa. All about creating that sideways force.
And you mentioned this earlier, but the rudder works with the ailerons, especially during turns.
You need both. A well-coordinated turn isn't just about banking. Got to have that simultaneous rudder input for a smooth, controlled turn.
Teamwork, even up in the air.
Exactly. Teamwork makes the dream work. And speaking of teamwork, there's another design for yaw and pitch control we should mention, the V-tail.
E-tail. Is it what it sounds like?
Pretty much. Instead of having separate rudders and elevators, the V-tail, it uses two slanted surfaces at the tail. Each one controls both yaw and pitch to some extent.
Clever. Two birds, one stone.
Exactly. It's all about efficiency.
So now I'm really curious about those solutions to adverse yaw. They sounded pretty clever.
Clever's a good word for it, yeah. Those solutions are pretty ingenious. Remember we were talking about adverse yaw? That thing where the aircraft wants to swing its nose the wrong way when you roll?
Right, like it's fighting you.
Exactly. Well, engineers weren't going to let a little thing like physics ruin a good flight.
Like I said, superheroes of aviation. So how'd they fix it?
One way is actually pretty simple. Elegant, you might say. Differential ailerons.
Differential ailerons. Okay, now you're just using big words. What's different about them?
Basically, they changed how the ailerons move. Imagine you're trying to roll right. With differential ailerons, the right aileron, the one going down, it goes down further than the left one goes up.
So it's not like perfectly balanced.
Nope. And that's the key. That extra deflection in the downgoing aileron, that creates more drag on that wing, and that counteracts the adverse yaw that would normally happen.
So it's fighting fire with fire, kinda? Or drag with drag, I guess?
You got it.
But hold on, I was reading, there's another type too, right? Fries type ailerons. What makes those different?
Those are cool. It's all on the hinge. See, a normal aileron, it's hinged basically right at the wing surface. But a Fry's aileron, the hinge is a bit lower.
Okay.
So when it's raised to make the plane roll, that lower part of the aileron, it pokes out a little bit, creates extra drag right there on the downgoing wing.
I get it. More drag to fight that adverse yaw. Sneaky.
Exactly. Built right in.
Those engineers, they think of everything.
They really do. And there's one more way to deal with it. You know, this one's all about connecting the ailerons and the rudder.
Oh, right. Heard about that.
Yeah. So with this system, when the pilot uses the ailerons to roll, the rudder automatically gets a little input too, just a tiny bit in the same direction.
So the system is like, hold on, I know what you're about to do. Let me help with that.
Exactly. Makes for a way smoother turn. Less work for the pilot too.
Sounds like a win all around. It really is crazy how these little design choices make a huge difference. And that's just the primary flight controls, the big three. There's still those secondary flight controls too, right?
Oh yeah, don't forget about those. They might be called secondary, but trust me, they're essential for specific stuff and just overall how the plane performs. Take flaps, for instance.
Ah, flaps. Those are those big panels on the wings, right? They come out for takeoff and landing.
Exactly.
Always makes me a little nervous, gotta be honest. But they're important, right?
Essential. Flaps, their whole job is to increase lift and drag. Basically, when they extend, they change the shape of the wing so it makes more lift, even at slower speeds.
Which you need for takeoff and landing.
Exactly. And that extra drag they make, that helps slow the aircraft down for those maneuvers too.
Makes sense. So kind of like ailerons, there's different kinds of flaps too, right?
You know it. You've got your plain flaps, split flaps, slotted flaps, even Fowler flaps, just to name a few.
Whoa, that's a lot of flaps.
Each one's got its own pros and cons.
So it's not one size fits all.
Nope. It all depends on the plane, how big it is, what it's used for, that kind of thing.
So many factors.
Aviation is full of them. Now, switching gears for a sec, let's talk about leading-edge devices.
Those are on the front of the wings, right? They always look smaller, less noticeable than flaps.
They are. And leading-edge devices, they're all about making the airflow over the wing better, smoother, especially when the plane is at a high angle of attack, like during takeoff and landing when the nose is pointing up.
Right.
Helps prevent stalls. That's where the airflow kind of detaches from the wing and you lose lift. Bad news.
Definitely bad news. So these leading edge things, they're like the wing's way of holding on to the air.
That's a good way to put it. And like flaps, there are a bunch of different types of leading edge devices too.
Of course there are. What would aviation be without options, right?
Exactly. So there are fixed slats, movable slats, leading edge flaps, and cuffs. Each one does the job a little differently.
Fascinating. It's really amazing how much engineering goes into just managing the airflow over the wings.
It's all about that airflow.
Yeah.
But you know what seems counterintuitive to a lot of people? Spoilers.
Oh, yeah. Why would you want to spoil the lift when you're already in the air? Sounds kind of dangerous.
It does, but they're crucial, especially when you're coming in for a landing.
Okay, so what do these spoilers do exactly?
They're like panels on top of the wing. When they're deployed, They spoil the airflow, make it messy, increases drag, reduces lift.
So are they like air brakes?
You got it.
Yeah.
Helps control how fast you're descending, and it makes sure the plane doesn't bounce back up after it touches down on the runway.
That makes a lot of sense, actually.
And get this, some planes use them for roll control too.
No way.
Yep, multitasking at its finest.
Love it. Okay, so we've talked about disrupting airflow. Now let's talk about something a little less intense. Trim systems. What are those all about?
Oh, trim systems. They're the unsung heroes of flying. Seriously. They make everything so much easier on the pilot.
How so?
Imagine having to keep that control stick held in exactly the right spot for, like, a long flight. Your arms would be toast.
I'm tired just thinking about it. So that's where the trim comes in.
Exactly. Trim systems take some of that pressure off so you don't have to work so hard to maintain altitude and all that. It's kind of like cruise control.
I love that comparison. Cruise control for the skies.
Exactly. And how they work is, the most common type is the trim tab. It's this little surface connected to the main control surface.
Okay.
Adjust that tab, it changes the forces acting on the whole surface. Helps the plane stay put, so to speak, without the pilot constantly wrestling with it.
Like a little helper for each control surface, making sure everything stays nice and balanced.
Exactly. And of course, some aircraft, they've got fancier trim systems. They can even adjust things automatically for best performance.
It's incredible how much is automated these days.
Right? All this stuff happening behind the scenes just to make sure things are smooth and controlled.
Love it. So, speaking of automated, I think we've got to talk about the autopilot. Autopilot, now we're talking like sci-fi stuff. But really, how does a plane fly itself?
It's not as crazy as it sounds. Autopilot, it's basically just a really advanced way of using everything we've been talking about. It can control where the plane goes, how high it is, all that, without the pilot needing to constantly adjust things.
Like a co-pilot who never needs a coffee break, but it still uses all those same control surfaces, right?
Yeah.
Ailerons, rudder, all that.
Oh, absolutely. It sends signals to those surfaces, just like a human would. But, way more precise, way more consistent.
Makes sense. But even with autopilot, I'm guessing pilots are still paying attention, right?
Yeah.
Not just reading a magazine back there.
Autopilot's a great tool, don't get me wrong. Helps with accuracy, reduces workload, all that. But it can't replace a human pilot.
Makes sense. Things change up there in the air. You need a person to make judgment calls. It's just amazing how far we've come from those early planes.
It really is something. We went from, literally just levers and pulleys to this super advanced tech. Hydraulics, electronics, computers. It's a whole different world.
All thanks to some very smart people. Trying to conquer the skies, right?
And doing a pretty darn good job of it, I'd say.
Makes you wonder what's next, you know? What's the future of all this flight control stuff?
That's what's exciting. Always something new on the horizon. We're already seeing some wild stuff with fly-by-wire and, planes that can practically fly themselves.
Like fully autonomous?
Getting there.
Yeah.
Imagine planes that can adjust to anything on the fly. Changing weather, finding the best route, saving fuel, you name it.
That's the future right there. Sounds amazing, but a little scary too, if I'm being honest. But I guess no matter how fancy things get, it always comes back to those basic rules of flying we talked about, right?
You got it. Lift, drag, thrust, weight. Those haven't changed. Those are what make a plane fly, whether it's a paper airplane or a jumbo jet.
It's all physics in the end, isn't it?
Always has been.
So next time I'm looking up at those jets leaving trails in the sky, I'll have a whole new appreciation for what's going on up there.
Me too. It really is a marvel of engineering when you think about all those systems working together to make flight possible.
A true symphony of science. Well, this has been a wild ride, learning about aircraft flight control systems. From ailerons to spoilers, we've covered it all, or should I say, flown through it all.
It's been a pleasure talking about it.
The pleasure's all mine. And as always, folks, keep looking up,